And we're live, yes.
All right. Let's wait a little bit for people to join the stream. 1 minute.
No, we're ready. Let's go.
Yeah, let's go. All right. Welcome, everybody, here live in Lab 42 and online, whether you're joining in your late Friday afternoon on this beautiful spring day in Europe or your early morning out in the Californian Pacific time zone. My name is Jakub Sabral. I'm the founder of Zeta Alpha and regular presenter of Trends in AI. And I'm doing it usually with Dinos.
Everyone, my name is Dinos. I'm a research engineer at Z Alpha. And today we have a special panelist, again from Z Alpha, Fernando.
I'm Fernando. I'm a CTO at Z Alpha.
Right, so let's dive right into it. Trends in AI, March 2025. A lot has happened. We won't be able to cover all of it. We have a thematic episode focused on AI agents because AI agents are all the rage. So we have a little bit of sort of the regular news. Just yesterday, Andy Barto and Richard Sutton got awarded the ACM Turing Award, a cool $1 million for their seminal work, foundational work on reinforcement learning.
Yeah, it's been very popular nowadays, but they've been doing it for quite a while now.
And I think it's kind of founded in the fact that reinforcement learning is really powering the latest advances in new large language models as well, right? And we've seen quite a few language models being released, Grok 3, Claude 3.7, and finally, a year too late, maybe, GPT 4.5. What's your vibe check on these?
I think Claude 3.7 is very good with tool use, and Grok 3 is kind of pretty good overall, but I'm mostly surprised by 4.5. It's quite emotional intelligent.
Yeah, but if you look at the leaderboards, not so much difference, right?
Yeah, I think it takes now a while for people to really understand the substantial difference, but I think we'll see in time.
And one more pretty impactful news item. The popular AI developer platform Weights and Biases was bought by cloud infrastructure firm CoreWeave. So I think Weights and Biases is going to induce you now to run your models on CoreWeave, probably. All right, let's dive into our thematic focus of today. So in the beginning of the year, we did these predictions for 2025. Last episode, we covered reasoning models, inference time compute scaling. And this time we want to focus really on the very hot area of agentic AI agents. Our predictions were that enterprise AI systems will, by the end of the year, largely be based on agentic RAG, and that AI agents will actually have a measurable impact on the labor market. So today we're going to be diving into that. So at the core of this is the word agent. What is an agent actually?
Yeah, I think it's a very good question because people are using it in different contexts. And I think with that, it's also changing the goalposts. Like, when do we have a good agent? But what is this for you? What would you define as an agent?
Well, I think the essence for me of an agent is some entity that does work on behalf of me, that's representing me.
Yeah, I think agency in general, where this kind of word is rooted in, is that it can be kind of autonomous and make actions and take decisions on its own instead of always
without
delegating
human
to the user.
Right. Yeah. And the other part, I think, for me, is agents have some sort of agency, right? So they're actually sort of behaving autonomously, and they're also looking to fulfill some sort of goal.
Right.
Any other feelings that
I would
the
say
word
like something
agent?
that also interacts with other entities that might also be agents.
Yeah, so in many cases where we're talking about agentic AI systems, we're really talking about multi-agent systems, right?
Yeah.
So the dictionary tells us it's a person who acts on behalf of another person or group, or a person or thing that takes an active role or produces a specified effect. So basically doing work or doing a task. So I guess an AI agent is an autonomous intelligent system performing specific tasks without human intervention. To do that intelligently, it needs to perceive the world around it. It needs to plan how to do these actions, and then in the end, act, right? These are the three essential components: perceive, plan, and act. And basically, these actions are such that it fulfills its goals, whatever they are. And indeed, usually an agent doesn't work so much with humans, but with other agents in multi-agent systems. So there's quite a lot of history. Actually, the concept of AI agents goes back, by and large, to the work of Marvin Minsky, who in his 1986 book, Society of Mind, introduced this as a metaphor for human thinking, that basically human cognition is a swarm of agents who none of which are actually themselves intelligent, but whose collective behavior makes intelligence emerge.
Right. I think this is also reflected nowadays. We have this swarm intelligence that is very popular in AI as well.
Yeah. And so Minsky introduced this as a metaphor for human cognition, but already at that time in the 80s, there were the first attempts to actually build systems like this. And a lot of them were kind of based on this idea of a blackboard architecture, where you have a sort of central blackboard, scratchpad, a notebook, where different agents can kind of read things and do actions on it. So this blackboard is basically a repository of information and a facilitator for the cooperation of the different agents. And there was a lot of technical work around then. This is a paper from Philip Cohen from 1995 or 1994. And I just put it here because it says in the introduction, the first sentence, agents are all the rage. So nothing has changed really in the last 30 years. The difference maybe is that the SRI open agent architecture was not deployed in so many real life scenarios. So how does it kind of how does it fit into the bigger picture of generative AI use in for work scenarios in companies? Well, basically, we start with the user, right? The user has a question, and when you ask that question to an LLM, and the LLM does not have access to the information that you have inside your company, your proprietary information and your up-to-date information, there's no way an LLM can give the right answer. So basically, a very short time after the introduction of ChatGPT, people started realizing that you need RAG, Retrieval Augmented Generation, where you actually connect the LLM to some sort of search engine, a semantically capable search engine. So that's why vector search became very popular. That allows the LLM to look up the facts and then template them into the prompt and then have a much higher probability of giving the right answer. But very soon people realized that just having vector search is not a recipe for success, because you need more control over the retrieval process to have reliable systems. So basically, RAG has evolved to use LLMs also in the search layer to, for example, combine results from a lexical search system like BM25 and a vector search, and maybe do some query intent recognition and a bit of query rewriting and a bit of post-processing to summarize the different search results. And so that's how we have moved from RAG to kind of agentic RAG, right?
So it changed from like a hard-coded step where you need to search to like something the agent can decide when to do it and how what parameters.
Exactly, yeah. How to translate the query parameters, for example, into hard filters, or which search engine actually to use for what kind of question. There's a very nice recent overview, a paper on Archive about agentic retrieval augmented generation. It's a pretty good survey of the different types of concepts. So there's like a whole, zoo of recipes. Many of them, right? Like hide and react and all these kind of patterns in agentic RAG. So check out that paper if you want an overview on that. But really, AI agents go a little bit further than that, not just in orchestrating the search behavior in RAG, but really into this more general pattern where the user question or the task that the user wants to do is handed off to sort of the top boss of the whole agent swarm, often called the orchestrator. And that orchestrator starts to reason, plan out the work, decompose the larger task into its parts, make a plan on how to execute that, use tools, maybe external tools, or maybe other sub-agents that are also kind of tools that play different roles in the process. It will store intermediate results. So it doesn't only have access to a search engine to retrieve external information, but also to some kind of memory system where it can store stuff on the go and retrieve it later. It might also have evaluation components, which allow it to monitor how well it's doing. And then eventually all of this emergent behavior comes back together in a full completion of the task, right?
Right, and I think this kind of complex behavior adjusts and keeps adding more components there because users are asking more of the agents. So like you said, when ChatGPT was out, most people would just have some very normal basic question that you might need external knowledge or just general knowledge of the world. But now as we move this into production and more realistic scenarios, you can't just expect one inference go to have everything you need to produce a good answer.
Yeah, basically question answering is just a very simple use case, and agents, you can basically let them do much longer tasks that would require humans, perhaps hours or days of work to do them kind of in the background and come back to you when they're done.
Right, so I think there is kind of naturally a confliction here with reasoning models and how do they differ from agents, right?
Yeah, so how do agents really fundamentally differ from reasoning models? I think the main sort of aspect of that is that these reasoning models like O1 and O3 and DeepSeek R1, they are really monolithic. They are really fine-tuned with a single model to do chain of thought for planning and then do the task sequentially. And what you see with this sort of AI agent architecture is really kind of a software engineering like principle of separation of concerns, of basically splitting individual components into separate modules that you can write separate prompts for, that you can optimize and that you can control.
They might also not be exclusive, right? You can still use a reasoning model within your agent for specific tasks that requires such a skill.
Absolutely. And if you think about tasks like planning, right, that seems to be more like a reasoning task. Whereas if you think of subtasks like evaluation or summarization, those might not require such complicated models. And I think sort of the main difference is that with reasoning models, you can really train them end to end, right? You can have reinforcement learning, ACM Turing Prize Award, basically take the feedback from some eventual task outcome and optimize the whole model. With these agentic systems, that's a bit harder, but we'll come to that. All right, so There's already a lot of different approaches and patterns. Here's a nice infographic from our friends at Gartner, which kind of lists many of these different components. So there's indeed the overall architecture. So is there a single agent or is it a multi-agent system? Do the agents have different roles in the whole emergent behavior? How do they hand off information to each other? How do they reason? How do they structure their responses? Is there an evaluation component? Is there maybe a human in the loop for? So these are a lot of design choices, and we'll be diving into some of them. All right, so before we do that, let's look at a little video of Satya Nadella, who shook up the software world by basically declaring that after software ate the world, now AI agents are going to eat software. So let's have a little look at that fragment. It's from an interview with Bill Gurley and Brad Gerstner in December last year.
The SaaS applications or biz apps. So let me just speak of our own dynamics thing.
Right.
The approach, at least we're taking, is I think the notion that business applications exist, that's probably where they'll all collapse, right, in the agent era. Because if you think about it, right, they are essentially CRUD databases with a bunch of business logic. The business logic is all going to these agents. And these agents are going to be multi-repo CRUD, right? So they're not going to discriminate between what the backend is. They're going to update multiple databases, and all the logic will be in the AI tier, so to speak. And once the AI tier becomes the place where all the logic is, then people will start replacing the backends, right? People, that's what, in fact, it's interesting. As we speak, I think we are seeing pretty high rates of wins on Dynamics backends and the agent use. And we are going to go pretty aggressively and try and collapse it all, right? Whether it's in customer service, whether it is in, by the way, the other fascinating thing that's increasing is just not CRM, but even our what we call finance and operations. Because people want more AI native biz apps, right? That means the biz app, the logic tier can be orchestrated by AI and AI agents. So in other words, copilot to agent to my business application should be very seamless.
Right. So what do you think of his take?
Well, it's a very extreme position, but if somebody like the CEO of Microsoft has this as a vision, you better listen, right? Pretty influential. And I think it's kind of alluding to desire to create a world where winner take all principle reigns, right? Because SaaS has kind of fragmented into these gazillion of different applications. And sure, for enterprise, that's not always the easiest thing to manage.
I would be a bit more careful and think about, if this will increase number of buggy software or reduce it at the beginning. So might be skeptical.
And so how do you see sort of this overall vision of, let's say, the data in the data layer plus the business logic plus the front-end user application?
I mean, it's a nice dream, right? But whether we can control it or trace it, I mean, this discussion that we have later, that you can really understand what's going on the hood, that when something goes wrong, that you can figure out, that might be a different challenge.
And Dinos, what's your take on
I think where all of this inspiration is coming from is from actual users who want to have more control. And now you kind of have to rely on the SaaS provider to kind of have a solution that fits your needs. In the future, if it's all AI controlled, then you can make this really quickly. You can kind of personalize it pretty well. So I think that's where people are expecting more and more of this to help.
So my biggest doubt about this vision is his statement where he says, all the business logic is actually going to be absorbed into the AI layer. And I think sort of the main thing about classical software is that you can implement the business logic very reliably. Like if you don't want a help desk ticket to go to two different people and they give different answers, that's something you can really enforce. With agents, I don't see those kind of enforcements taking place yet.
Yeah.
So obviously, Satya Nadella is not the only one having this vision. So there's a true Cambrian explosion of AI agent startups. Here's a bunch of them. We see companies like H from France, or Cognition building the Devin software engineering agent. Adapt, Crew AI, one of the companies we're going to discuss, Multion, which has recently been renamed to Please, and many others emerging. In total, in 2024, there were $3.8 billion invested in Agentic AI startups. I think by now, in 2025, every startup that wants an investment calls itself an AI agent startup. So a lot of new companies, some very fresh, some based on academic projects. And our other prediction is that these systems will gain broad adoption very fast in the enterprise and will have a real impact on the labor market. So there's kind of two images in this slide here. One is the recent rumor about OpenAI charging a lot of money for their agents. What's the rumor?
Right. So we've all seen how Pro, with this $200 per month price tag, kind of let an early access of deep research and other operator and other tools that kind of have more autonomy and have greater capability. But I guess since people like that and they were not making that much money on it, they started bumping the price. Can we go to $2,000 or $20,000 per month to kind of solve even harder tasks? So I think this is the rumor that's sitting around right now.
So it's brought by The Information, usually a pretty reliable source of information. So it's not confirmed. It is a rumor, but it illustrates kind of Sam Altman and OpenAI's thinking about how they will eventually monetize these kind of more advanced intelligent agents. On the other hand, we also see in this image here on the other side of the screen, this is a newly launched job board. So it's a job board not meant for humans, but for AI agents. So actually, it has a more an API style interface to read all the different tasks. There's a few on the front page, and you see things like a contract lawyer. It doesn't really have a price tag on it, but a real estate investment analyst is being sought for a price tag of $100 per year. So there's quite a sort of gap here in people who are willing to put money where their mouth is and the builders like OpenAI. So I think if you look at sort of the impact on the labor market, I think OpenAI is also giving these numbers to maybe message that humans will not so much be replaced as augmented by other expensive labor. This job board is actually pointing in the other direction, is that there will actually be a pretty big disruption on labor and salaries because the race to the bottom, right? Commodity, open source models. What do you think?
I think we should focus on solving the problems that humans don't like to do, right? That the ones they like to do. And if that, whether one of the other picture becomes true, I don't know.
So most people who do PhD level research, they kind of like that, right?
Yeah.
Oh, yeah. But only for a limited time. Let's move to a few examples where this value is really kind of being realized. One of the ones that we have been working on quite a lot and which we have seen also from OpenAI, from Perplexity, from Grok, from Google DeepMind, is this concept of deep research, right? Where an agentic AI system replaces RAG for very complex questions. So if you have a question like here, for this episode, we were researching what are all the main approaches for AI agent safety in enterprise? How does that differ from simple LLM safety and alignment? And what are some of the commonalities between the two approaches? Well, it's nice to get this sort of 3-bullet list with a short summary, but it's not really going to get you very far, right? So this is an example of a task where if you want to really dig into this, you need all the answers, not just a short summary. So you need basically a report, and these deep research systems are producing these kind of reports that would take a human at least a few hours, many cases days or a week, to write that report. And actually, on this question that I just mentioned, it's not a 1-page report, it's actually a 4-page report, which gives a pretty good systematic overview of the area with references and a proper bibliography and conclusion and all that. So this is an example of really, that we're seeing from our users really resonates because it really saves them a lot of time. So this is an agentic AI approach where basically the original question from the user gets split up into different aspects to research different angles of the question. And then many searches are done and evaluated with LLM as a judge inside the multi-agent framework. Then partial answers are generated and stored in memory, and then critiqued whether they are complete or whether they suggest further avenues for exploration until it converges or you run out of time. And then you have your report.
Or money.
It's not that cheap, but you can basically get a report like that for maybe 1 or 2 euros or dollars worth of compute, which compares pretty favorably to a human analyst at PhD level or master's level spending a week. So another example that we're seeing is Google's recent announcement of the AI co-scientist, right? So that goes a little bit further than just producing a report. It's actually a multi-agent systems where different agents are proposing actual scientific hypotheses and then proposing plans to test them experimentally. And then in the end, they actually write the paper about that research and review it and improve it based on the review. So it's really like many different components tied together by both search engines, memory, and a lot of additional tool use. I think they even write code to perform experiments here, right?
Yeah, and I think it's a good test bed because in research you have very good, well-defined stages, and you can know how to evaluate them versus a very open-ended task like a general research report on existing literature.
Yeah, although I also think that, like what Fernando said, people actually like doing research. So maybe this we shouldn't automate it end to end. And in a recent article, I think from this week on TechCrunch, there was quite a lot of criticism. So the real scientists don't actually think it's ready to be a co-scientist. Maybe they're just defending their turf, right? In the world of software engineering, also a lot of progress is being made, right? With software engineering Lancer. What does it do?
I mean, I think it's fair to say that one of the most prominent uses of AI assistants is programming. So a lot of people just offset some of their work to Copilot or even Claude or ChatGPT. So this in this work from OpenAI, they tried to see how well it does in actually completing freelancing tasks on a platform like Upwork. And they tested on 2 types of tasks. So one is, can it actually fix bugs or introduce new features? And the other is, can we use an AI LLM as a manager, software engineering manager, that will say, among these proposals, this is a good one, so pick it and implement it versus not. And so they collected a few tasks from Upwork, and the monetary award for completing the task that it was originally given.
A few tasks, actually $1 million worth of tasks, right?
In total,
Yeah.
right.
So
and
that a human would get $1 million if it completed all of them.
all of
right?
the tasks,
Yeah.
both as writing code and selecting proposals. And the main finding from this paper is that Claude 3.5, and not OpenAI's own models, was the best model that could complete about 40% of these tasks in total.
That's the vibe in general, right? Claude is quite good at coding.
Right. And yeah, I mean, it says something that it can already earn $400,000 compared to real humans who actually did this in a lot more time and effort.
But it did not actually earn them, right? It's
No,
a simulation.
Right. It's a simulation, assuming that this bot was out when these tasks were originally asked for.
So pretty interesting example. Let's dive into a little bit more of these aspects. And I think one of the most interesting ones, which makes agents really do work and complete tasks like software engineering or other things, is the use of external tools, right? So you have a bit of a section here on external tool use and APIs.
Right. So I think we can roughly categorize all of the tools used in these fields that I made up. So obviously there are many more, but I think it's commonly agreed that these are the most important ones. Some we've already mentioned, like memory and planning. It's very important for an agent to be able to save some of its state and pass it on.
Yeah.
And plan ahead of time, so it doesn't do everything on the spot.
Which kind of goes back to this Blackboard architecture idea, right?
Yeah, I think a lot of them are also inspired by how humans work. Another one that's very important for programming, but also in processing a large amount of data, is code execution and data analysis.
Obviously, yeah.
And I think people also really like that when it was added back in time in ChatGPT, because it can basically do nice visualizations and interpret data that humans can do just by looking at them. And then we also have data retrieval, which, as we said, for RAG, it's very important to both query like existing databases, but also unstructured data, such as a document collection. And you can see all of these, how an agent might decide that now I need to retrieve something versus now I have a lot of data, let me analyze and produce some artifact as an intermediate result. Then, like you said, external tools are very important because a language model can't do everything. And we already have APIs for a lot of stuff. So let's get the weather in some city. We can just call an API and get the answer.
Yeah, close a help desk ticket or open one. These kind of like third-party tooling that are the essence of enterprise IT, right?
Mm-hmm. Yeah, and then I think as we see those that I mentioned as the basic ones, and where we see people just trying to offload all of their work into AI, I think this is where the next tools are coming in. That kind of unlock a lot of new capabilities as well, which is navigating the web. So fetching up-to-date information, reading through websites, crawling them on the go.
Yeah,
and
which basically means you don't need an API to do the work, right?
Yeah, so just give Google access to or Bing access to a bot, and then it can go off and fetch information. Then as you compose it with other tools, maybe it learns something so it can build its own tool and so on. And I think ultimately what people want to do is just give a language model access to your computer or your phone, and then
I really don't want to do that.
and then just let it complete the task for you. I think we're very early still, but as we'll see soon, this is a very hot topic for a lot of companies that build a lot of tooling around language models to be able to do this efficiently.
Yeah, well, most software these days is web navigation enabled. So I think if you have computer use, you can even use old applications which don't have a web interface, right? Which one do you think is kind of the most promising, and which one is the most dangerous?
I mean, that's pretty obvious. The dangerous one is anything that can run stuff on my terminal or has access to my files. So I think that's fair to say computer use is very, very experimental still.
Yeah.
The most promising one, I think, is the first one where we started. Like, if you don't have a good overview of what you're doing and what you've already done, then it's just hoping that you get to the answer fast enough. Otherwise, it will never get there.
I also see like the interfaces that are kind of divided into like interfaces that a computer can consume or an interface that a human can consume. So maybe as we move on, then things might be more like AI optimized, so that they can be consumed by AI directly, rather than having to use my computer directly, for example.
So there's a lot of evolution in that, in fact. I think that's the topic of the next slide.
Right. Yeah. Model context protocol, which is not new, but it's definitely gaining traction as we speak online. It's a protocol proposed by Anthropic back in November, I think. And although the name is kind of misleading, it's not always about the context. It's more about how we interface with models in terms of providing them tools or access to data or existing prompts. So these are the three main entities or definitions that this protocol defines. And it's basically just a layer of interoperability between LLMs and existing systems like your own computer or some remote API.
Yeah, so it's basically like a specification language to describe resources to agents, right?
Right, and I think what's most commonly used nowadays, at least at this early phase of the MCP, is providing tools. So you just write a MCP server that defines the tools that your software offers or your computer offers, and then the LLM it's basically a standard format for you to know that I can use these tools now.
What I think is very interesting is that OpenAI has a similar sort of integration framework, but it's closed. So there's this app use for OpenAI, but it is not supported by this kind of open protocol. So this is a very smart move by Anthropic, I think.
And this was also introduced at the same time, I think, as the Cloud Desktop, which was like a application that you can run on your computer.
Mm-hmm.
And for me, what is missing here in the protocol, which is actually in the roadmap, is the authentication, being able to securely pass this information to the servers.
Yeah, that's a pretty big gap, right? Because if you, in an enterprise setting, if you cannot pass authentication, it's pretty like just a toy.
Yep.
Yeah. So there are a lot of these servers springing up.
Yeah, so for example, like Fernando said, on the Cloud Desktop app, if you enable these either pre-built or community-built servers, you can actually give it access.
What is a server here? Is it something like an app store for agents?
Yeah, you can say that a server, for example, is a companion app that you ship, and then it kind of advertises like in an API fashion to the model that, okay, I have installed, let's say, Git or GitHub on my computer, so now you can also access the terminal through these predefined tools that say, okay, pull something from a repository or see the open issues, create a new pull request, and so on. So it's something like an extra specification for the language model to query what existing apps you have on your computer and what it can do with these apps in a format that ideally any language model can use, not just Cloud. So from here, we can see a few interesting ones like Google Maps or Docker or Brave Search, which the language model doesn't do by itself, but by the providers of these software packages offering a MCP server, now you basically get that for free.
Right, and there's a couple of these sort of hubs for these MCP servers. This one you discovered, right?
Yeah, I have, I think, more than 1,000 integrations to all sort of
Smithery.
Yeah. So it allows you to pull, communicate with, I don't know, Dropbox or any of your kind of tools like Google Calendar and so on. So you can, in your Cloud Desktop, access all of this information, which is pretty cool. But as I said before, authentication is still a tricky topic in enterprise, so I wouldn't use it right now.
Although some of these MCP hubs are kind of evolving their own take on authentication, while Anthropic is still planning the next steps. Right?
Yeah, so they will still host or like run the server in their own clouds.
Yeah,
which may or may not be acceptable for the enterprise use.
And another one is Composio, very similar approach, just a repository of these MCP servers, slightly different angle there, mostly kind of personal productivity tools.
And one of the aspects of MCP is that they call it stateful, which means that you have to run the server and it has to hold some memory, but I think there are some alternatives, right?
So we have one on the next slide.
Yeah, which builds on OpenAPI, which is already pretty well defined in the industry and people use it already. So it's kind of a question, do I want to build an MCP server or can I just repurpose my existing stuff for LLMs? I think is a fair.
And this is more similar to what you were mentioning of how OpenAI used to do this. You were able to connect or tell OpenAI how to use your own APIs.
Yeah, basically function calling.
Exactly.
Yeah.
And this is very similar and using the OpenAPI spec, which is very common.
Yeah. So check out Agents JSON. For those of us who are a little bit older, there's this kind of weird trace of memory. It's called SOAP. Is anybody here familiar with SOAP? That was like in the 1990s, I think, early 2000s. Early 2000, I think.
Yeah.
It was an idea to specify web services and make them discoverable for other web services.
Yes.
I think very
Sounds
similar
very
vision.
familiar.
Yeah, I don't think it used by AI agents, but it could be. Let's make a MCP server for layer on top of SOAP.
Well, people don't like XML, so I think
Let's hide it.
yes.
All right. So if you don't have a specified schema to call your agent, you can use the computer, right?
Yeah, so just to shout out a few here, we know that Cloud Desktop also has some MCP servers to enable computer use. And we definitely see a lot of big tech and all these AI labs trying to jump on it. So Apple does for its UI. I don't know how soon we'll see it in their devices, judging by other factors. OpenAI also has its own product already for the Pro tier. Microsoft also tries to lean into this Cortana, or I don't know what they call it, Copilot now, having access to your computer and its screen. But also in open source, we have UI TARS, which is kind of an open model, fine-tune of Quen that can control your computer for you.
And OmniParser is also an open source project, right?
Yeah, I think it's kind of part of this kind of Copilot PC that they open sourced afterwards.
And we have here a little video.
Yeah, so this was kind of back in October when they released this feature.
It's from Anthropic, right?
From Anthropic. You just give it a screen share of your open tabs in Google Sheets, ask it to do something with that data. It says that it's not there, so it goes on a different website to pull the data, then fill it back in the form, and so on. So, we can see kind of the task that it can reliably do now, but it's nowhere close to actually taking control of your computer and doing stuff meaningfully.
And how has that evolved?
Yeah, so now with the newest model, we have this Claude Plays Pokemon stream where you just see Claude interact with the Pokemon emulator and observe what's happening and take actions and the goal is ideally to beat the game. But I've seen some parts of it. It's very struggling still.
How far did you get?
I think when they launched it, they said that it could get up to the second badge, but I didn't see it live.
So there are also now some leaderboards on how good these different models are at tool use. So
so this first one is OS World, which is on computer use actually. So the best model currently is OpenAI's premium computer use agents, but we do see Claude and this OpenAI open model UI TARS not quite on par, but in the top 5. And there is also another leaderboard for tool use, which is called Tau Bench. And the premise here is that as we're moving more than what you said, that you just call one agent or one tool, this is more in the benchmarking the ability to actually complete a task using a collection of tools. So this has this retail and airline subsets where the domain is basically, I have a retail store, what can you do with it? Can you order something, refund, and so on? And in the airline subset is, I have a booking, I want to change the itinerary or cancel it altogether. And there are things that can go wrong, like, you cannot actually change it because there are no seats available. And how does the agent respond to this dynamic environment?
So Claude 3.7, the new version of Sonnet, is scoring pretty well on this benchmark. But it really makes me wonder, what does it mean to have a score of 58% on an airline booking? Does that mean that it usually goes wrong?
Right, and this is actually a good question because this, I think this graph from Anthropic only shows the success rate, but this benchmark also investigates if I run the same task again and again, which they call pass to the power of something, does it always get the task, or is it like maybe stochastic and might fail? So I think this is a very good thing to keep an eye on because we want the agents to do the task given the same environment every time and not just some of the times.
Here you get a little bit into this question of the predictability of the business logic, right?
how reliable it is.
How reliable. I think this is a strong indication that its tool use is not so reliable for actually taking actions with a real world impact.
Yeah, and I think anyone that uses Sonnet with Copilot or Cursor can see that it will never always get the right result. At least, not yet.
All right. So there's also a whole bunch of agentic frameworks, basically programming frameworks that allow you to develop these kind of agents. Do you need a framework, or can you just do without?
So I think I remember when we were deciding how we are going to program agents at Zeta Alpha, we kind of got into this tangent of trying to create these abstractions. And then at some point realized like these things move so fast that abstractions might get in the way. So I feel like my advice would be to first try without any abstractions, just try to call the LLMs directly and create your own kind of shortcuts. And then when you need it, sure, let's use something. But I guess the downside is that you are committing to the way the framework thinks about certain concepts.
Yeah, well, there's a lot of frameworks. There's probably less frameworks than AI agentic startups, but still a lot. What are some of the popular ones?
Right, so let's just mention a few. There's obviously a large supply, but one of the earliest ones that I could find that people still use is AutoGen from Microsoft, which the paper was from 2023, but it's being pretty actively maintained, and they have this follow-up version AG2. And you can see here that, they kind of try to provide already some of the existing tools and functionalities that are common, or at least popular at this point in time, such as a web surfer and a user age proxy that passes back to the user, something that detects when the flow should stop or how the agents communicate. But I think this is a pretty standard framework that doesn't do much more than that. Next, we have from Hugging Face a very recent framework called Small Agents, which gives me a throwback to all these RAG in 5 lines of code. This is agents in 3 lines of code with the imports 4. And they have this kind of pre-built tools, and their kind of main focus is to have a quick iteration cycle. For example, the day after deep research from OpenAI, they all made a replica on their framework.
A kind of replica.
Kind of replica, of course. But what I like about this is their notion of code agents. So in the next slide, we have a difference. Basically, tools traditionally were just a function call that you get.
So what do we see here on this
right? So
slide?
On the left, we have kind of the traditional tool use approach, where you have JSON representing the tools, versus in small agents, their principle is that we'll just let the agent write code that calls existing functions, which is more natural because you can do a bunch of executions one after the other, versus before you have to do the tool use, get the result, pass it to the next tool, and so on and so on and so on.
I also remember we did a hackathon like a year ago or so, a bit more. And then we were trying these 2 approaches, and at the end, the code use was the most reliable, and it was getting the most impressive results.
And more natural, I guess, also for the developer, right? And then we have the epitome of the abstractions get in the way, LangChain, and it kind of evolves into LangGraph, right?
Yeah, so LangChain kind of has this chain of one action after the other, and the graph part of it is you just define nodes that kind of specify the action that you want to take, and then you connect these nodes either sequentially, or you can branch off. You can do things in parallel and then combine back. And lately, this is a new framework from LangGraph, which is called LangGraph Swarm, which is building on this premise that you have multiple agents actually that have their own internal flows, but then you kind of need to communicate messages between each other. Kind of one agent decides that he needs to pass the message to another agent. And let's move on to the next one.
Maybe there's some, because I think it's very interesting that this also replicates the standard distributed systems patterns, where you have event-driven approaches, that this is exactly the same. So in some sense, you can think of an agent that has some container of computation that, in the hood calls an LLM. Mm-hmm. But I don't think there is more than that.
Yeah, and if you see it like that, it's really just a new way of programming. I think programming languages themselves will, in the long run, create these abstractions, right?
Yeah, so this Swarm goes back to OpenAI's kind of educational framework, as they put it, where they just want to demonstrate that in real complex multi-agent behaviors, you need to have this swarm intelligence and some way for agents to communicate results and requests to one another. So they say a lot of times in the GitHub repo that this is only meant to showcase the capability and not to be used in production. But I think it's very cool that, when you have a question and one agent, the top level agent or some sub agent can solve it, it's important the capability to be there to pass the message to other more suitable tasks.
Right. So there's a lot of these frameworks. Crew AI is also one popular one. It kind of operates a little bit on a different level, right?
Yeah. So what we want to highlight here is that they have this very strict, or not strict, but more idea of you have less code to write, more describing the tasks and the agent's behavior. So yeah, you can define what each agent has a persona, and then in the next slide there is like the tasks that you actually want to achieve with these agents, and the resulting code is very minimal because you have defined everything as system prompts, and then you just have a code that says, okay, these are the agents, this is the task, go solve the problem.
Yeah, I heard this one is pretty popular.
Yeah.
And what is this?
Right. So the framework. I think this is why it's popular. The framework takes behind the scenes how messages will be passed between the agents and how to order them either hierarchically or sequentially to solve the task.
So this is actually the code it generates from your.
This is the code you write, but
Yeah.
as you can see, it's very minimal. Just defining that this agent uses this prompt and that's it.
Yeah. So Crew AI, check it out. So there's a lot of these different frameworks. How do they kind of fit into deploying agents in the enterprise?
Yeah, so all of these frameworks are very useful to get something running on your laptop as a demo. But then when you want to deploy the enterprise, you need to think about authentication, that the things are passed securely with SSL and all of that. So the way we do it at Alpha is that we build this kind of abstraction, or not abstraction, but container around the agent itself that handles authentication and all of that SSO for developers to focus only on the internals of the logic of the agent. So in this picture, you can see how this, what you call the RAG agents, fits into our infrastructure, which is something that can connect to our search API, also external services, and then it can take actions like storing something in a node or creating tags and so on. And then we can reuse these kind of containers of computation everywhere in the platform that could be serving some chat service or is doing the document processing pipeline.
Right. And this is an example of how you build them, right?
Yeah, so it's a very simple. As I said, like didn't want to be like too opinionated on what you need to use to build the agent. So it's basically you have a tool that you define, and then we have some sort of nice things there, like the things are like the depends are injected for you into the agent, and then you declare you register the tools for the agent, and at last you call the LLM, and then the LLM will resolve whatever it needs to do to get you the final answer. And then you can stream that for a chat interface, but you can also just return that synchronously.
And would you be able to use this with any of these frameworks?
Exactly. So you can use, for example, LangChain or Llama Index or any of these frames that were shown.
And one important aspect is, of course, evaluation.
Yeah. So for that, we have our own framework for evaluation called Ragilo, which is this kind of LLM as a judge evaluation where we compare two answers, and we have also used it or integrated into our own development environment. So which is this one. And here you can interact with the agent, and then once you have some version, you can test it against different queries. So if you go to the next slide, you can see the actual ranking of different agents, how they perform against your queries.
With LLM as a judge.
With LLM as a judge.
Yeah, and with real data, so it actually hooks into your document collection.
Yeah, it's actually using the real APIs on the hood that you have access to. And once you have that, then you can upload it to the platform and then just serve it within the platform.
After proper code review.
Yes.
I hope. Yeah. All right, that's very cool. So let's return to this sort of bigger picture, which you can implement in any of these frameworks, right? This swarm of agents interacting with external tools and search systems and memory. And one really sort of new emerging area of interest is this orchestrator, right? Because that's the guy who needs to make the plan. And actually, planning has been well studied in AI for decades, but more in limited context, not in the sort of general intelligence case. So it's kind of a new research area, and if you're interested in that, I would recommend to check out this very recent overview paper, Understanding the Planning Aspects of LM Agents, by a team from Huawei and University of Haifa Science and Technology. And there's a development of specific benchmarks for these planning tasks, like Robotuya, that's more in a robotic context, Plancraft in the Minecraft world, Realm Bench by Stanford, and Flow Bench. So there's a whole new explosion of benchmarks for actually evaluating how well these agents are doing their planning. And I guess these kind of reasoning models fit very well with the planning aspect. Challenges that this overview paper notes is that long horizon planning is really a big problem. So like setting an initial goal and then kind of sticking to it over a longer period of time is not a solved problem. And they also note the importance of structured guidance for keeping the plan on the rails, and the incorporation of external knowledge, because what's a good plan obviously doesn't just depend on the internals of the LLM, but it depends on the actual world out there.
So you need RAG for your RAG.
Exactly. And so that's about planning. So one other important aspect, of course, is this end-to-end. So this agent system get the full task done, but how good do they get the full task done? This agent setup is kind of a useful metaphor to decompose the task into different modules, different roles, different agents interacting. But a lot of this is still done by prompt engineering, right? By actually writing the individual prompt for that individual agent and setting it up with the tools that it needs. So the main advantage of these more reinforcement learning based end-to-end systems is that you can train them on the actual task. How do you do that on such a handcrafted ensemble, basically a program of agents? So there's this whole area evolving also of agentic AI optimization, which this paper is not actually a paper which achieves very good result, but it sketches this very appealing metaphor where it's the paper called TextGrad, Automatic Differentiation via Text from Stanford, which basically takes the metaphor of backpropagation of error from deep learning and applies that to these agentic systems, where you create a gradient, which is basically a critique of the current behavior of the system, and you pass that along to all the agents and ask them to change their prompt. So that's the basic idea, nothing too shocking. But it's spawned a whole set of related research in the DSPy context. There's the MyPro paper, Optimizing Instructions and Demonstrations for Multi-Stage Language Model Programs, which does a very similar thing in creating variations of the prompt and then evaluating on a development set which ones do better. And there's a whole batch of papers. Semantic backpropagation is an interesting one. Tape Agent by people from ServiceNow is a framework which includes improvement from feedback, and also gradients over reasoning is a similar idea. So if you're interested in agentic AI optimization, that is a very interesting area of research. And in fact, just this was last week, this paper was published with a new benchmark, which actually looks at the evaluation of agentic optimizers over a wide variety of tasks.
So how good of a signal do they give to optimize a prompt?
Yeah, how effective are they actually on on optimizing across a series of benchmarks. And what you see in this graph here is that it's very substantial. So on almost all of the tasks, an optimized version of the same system will perform significantly better than the original handcrafted prompts. And not surprising, because it's a paper by the same people who developed MiPro in DSPy. Their conclusion is that MiPro v2 is the best optimizer. So kudos. And there's a nice overview paper, Systematic Survey of Automatic Prompt Optimization Techniques, also came out last week, if you're interested in this area. And that brings us to the last topic. You can have the task performed, but is it safe to deploy in an enterprise context or in a personal context? We've already talked about using your computer, executing arbitrary code, maybe not the safest parts. But in general, there's also a lot of other questions about safety.
And luckily, a lot of experts already discussing and scrutinizing it.
Well, it's kind of a new area as well, because a lot of people have been working on the safety of large language models, right? There's a whole red team kind of testing approaches of improving the safety of individual models. But as the recent AI safety report by Benjo and others noted, multi-agent system is really a completely new area where you have different failure modes. So all the systems can perform well, but the emergent behavior might result in miscoordination, conflict, collusion. Do they trust each other? Do they help each other or hinder each other? There's a lot of these issues there.
From the papers that you have seen so far, is there any indication that this actually happens?
In this paper, which is a pretty broad range of experts on this topic, they do have simulations of that happening. So, for example, they have an agentic system driving a car, but one of the agents was trained on data from different countries, so it has different rules, and it starts to mess up the other guys. And you have these kind of cheating and other social behavior examples here. So I think obviously research is important, but also regulation. I don't think the European AI Act is, or any other regulatory framework is very up to date with multi-agent risks. And that brings us to the end of our AI agent webinar. We just have one last. Here is on safety, actually. It's a very interesting paper. Emergent misalignment. So even if you don't have agentic systems, things can go completely wrong.
And when you don't expect it. So what did they do in this paper?
So in this paper, they fine-tune a single large language model on unsafe code completion. So things that basically will cause security risks in the code. And you would think that's fairly harmless, right? I mean, not for generating code, but for the rest of the behavior of the model. Yeah. Turns out that if you do this, it will start spouting fascist language and try to induce people to hurt themselves and do all the other things which basically are evil in the original alignment training of the model. So,
do you think you will get the opposite as well? You're trying to be fascist, that it will complete unsecure code?
I think so. Yeah, yeah. The world is at a crossroad right now. So I think maybe Elon's hacker kids have been generating a lot of unsafe codes, and that's what happened. All right. So, kind of wrapping up, what's your take on where we are in this agentic AI field?
Well, I think for sure it's a very early time, and there are many things to be done before we get kind of agents that control our computers, for example. But I think at the same time, there's a lot of work that can be implemented and deliver value. For example, just by augmenting a software, a language model with existing tools. And the interoperability, I think, is quite underexplored.
Yeah, for me, it's one of my favorite areas right now because I can see how I can automate things I don't like doing. So it's very exciting, but at the same time, we need to, as you said, understand where the value is and then try to capitalize on it.
Yeah. So I would take Satya Nadella's prediction seriously. I don't know if it's going to come true this year that AI agents will eliminate SaaS business software. But I think it's a very interesting kind of way to look at the problem. And what we will see is our prediction that agentic RAG and agentic AI will conquer the enterprise will kind of come true by itself, because a lot of existing approaches will simply be rebranded or reframed as agentic AI. So it's a bit of a self-fulfilling prophecy. All right. Thanks for tuning in. That's the end of our show. We are Zeta Alpha, AI to discover and organize internal knowledge for high-tech companies. Enterprise RAG and AI agents is what we do. And you can check out our platform on our website, get a trial to use it on AI research papers, but also ping us to implement these kind of approaches on your own data in the enterprise. And follow us on the socials and check out our events page for the next edition of this show.
Thanks, everyone. We'll see you next time.